Okay, so now we're going to move on to number 5. And it reads, the tangents to the curve y squared minus x squared is equal to 4 pass through the point 0, 1. And it says, find the coordinates to the points of contact of these tangents with the curve, and then finally find the equations of these tangents. So, of course, let's proceed with A, and we're just going to treat it as it passes through the point 0, 1, and keep it nice and simple, denote as our point of contact as A, comma, B. So, point of contact, AB. And we'll put that in later, right, after we differentiate. So first thing we want to do is differentiate, of course, our parent function. So what I want to do is, this is going to be 2y, and then again, I just prefer the y prime notation because it keeps my paper slightly cleaner, but again, you can use dy over dx, minus 2x is equal to 0. And now, isolating for y prime, I move 2x over to the other side, so 2y times y prime is equal to 2x, and then finally y prime is equal to, what do I have here, 2x over 2y, which is just equal to x over y. Okay? And remember, this is the slope of my tangent. That's what it always represents. So, this is one expression for my slope, and remember our slope formula, y2 minus y1, x2 minus x1. So, applying this formula to our question, we can also have our slope be equal to b minus 1, and, well, a minus 0, right, using the points that, or not the points, the coordinates that were given, 0, comma 1. And now, I have these two equivalent expressions, right? I have got, well, x and y, but remember when I sub in x and y, we're going to use a and b for our point of intersection, will be equal to our other expression over here. So I end up with a over b is equal to b minus 1 over a. And here, when I cross multiply, a times a will give me a squared, b times b times b minus 1 will give me b squared minus b. So we have an expression over here. So now we're just going to manipulate our equation to get a squared is equal to b squared minus b, right? But what else? A squared is equal to what? Is equal to b squared minus 4, right? Because this is just an algebraic manipulation of the curve that we were given initially. Oops, sorry. Only we've got a squared, b squared, right? Replacing x and y respectively. And then if I isolate for a squared, that's where I get my 4 from. So don't worry, I didn't just magically invent this. It's just a manipulation. I'll write this in the notes. Manipulation of initial expression. Okay. Oh boy. It's getting that time where I start making simple spelling mistakes. Okay. So that's our manipulation of our expression, and now when we equivocate these two, I'm just going to sub in b squared minus 4 to replace a squared here. So b squared minus 4 is equal to b squared minus b, which we can plainly see. Obviously, we can cancel these two out. So I get negative 4 is equal to negative b, or in other words, b is just equal to 4. Okay. And now that b is equal to 4, we can just do a straightforward substitution to find out what a is, right? So if a squared is equal to b squared minus 4, I plug in my value of b squared, so a squared is equal to 16 minus 4, so a squared is equal to 12, and then square rooting both sides, I get a is equal to plus minus my root of 12, which can be simplified to be plus minus the, I have to leave a little bit of room, taking as much out of my radical as as much out of my radical as I can, 2 root 3. And the plus minus makes sense, right? Because the initial question tells us, it says that we have tangents to the curve, right? So I'm expecting more than one value. So my points of contact are going to be, where should I put my answer? Points of contact will be positive 2 root 3 comma 4 and negative 2 root 3 comma 4. Okay, so that's it for A, and now we've done most of the work. We just need to find the equations of these tangents, and obviously the numbers are not as pretty as you would get them in grade 9, but we have a point through tangent number 1 and tangent number 2, and we have a point that they both share, right? They've both got 0, 0 and 1. So that's what we need to do. So just separating this a little bit so we can see part B. My slope of my tangent is going to be A over B, which is equal to plus minus 2 root 3 over 4, which of course simplifies. I can cross out the 2 and this becomes a 2. So I get plus minus the square root of 3 over 2. And I just need to use the positive value for one tangent, the negative value for the other tangent, and then I can find my equations. So for tangent number 1, I get y minus 1 is equal to the root of 3 over 2 times x, well, minus 0, so that's going to be nice and easy, which simplifies. It doesn't even specify which form we need to put our line in, but I'm just going to put it into slope-intercept form. When I manipulate, it's going to be y is equal to root 3 over 2x plus 1. And I just rinse and repeat the process. The only small change is this slope is now going to be negative instead of positive, and then we can call it a wrap. Y minus 1 is equal to negative root 3 over 2 x minus 0, which again, when I rearrange it into the same form as the first tangent that I did, y is equal to minus root 3 over 2x plus 1. Okay, so hopefully those two questions made sense. Again, I'm not going to upload question number 6 because we would be pulling ahead of the other class for no reason. Plus, it's getting pretty late and I'm pretty tired, so I don't want to accidentally make any algebraic mistakes and then confuse the class. I think it will just be better if we wind down after our assessment on Friday and do number 6 and probably one more implicit differentiation question after our assessment. Okay? Alright, so have a great Thursday, and I will see you Friday. Study hard, but also make sure to get a good night's sleep.